Hi, this is Dr. Schulman. We're going to jump into this video about sequencing lessons, sequencing examples within lessons. I'm going to show you a few of mine, lessons that I've made, tweaked, pushed around. Feel free to steal them. The best way to, there's no one way to teach something, so feel free to grab as much knowledge as you can from these. And I hope these are useful. So I'm going to share my screen. And I'm gonna move this. I'm gonna go right into this set of notes, math for teachers, and we're in curriculum sequencing. And I'm just gonna jump right into it. Well, I'll give a little bit of information first. So when you're making examples, right? When we're sequencing examples, the best thing you should do is start with some like free skills. Build off what the students already know, okay? You're due now or bell ringer or intro, all of these things should rely on their previous skills and kind of what they are bringing, what students are bringing into the classroom with them. Now, this could be from a previous lesson, which you'll see. I'll have it do now from a previous lesson, like kind of help them. You'll also see me using, just trying to gauge their knowledge using a which does not belong to just kind of gain what they already know about the topic beforehand. So that should be like the first type of things you do with your examples. The next thing you should always do is build skills from easy to hard. Okay, that should be your first idea. Make them as simple, make them really confident, have students have this idea of like, okay, I got this, and just kind of incrementally get harder. You don't want to throw too much new stuff at students. Students usually have this feeling that math is scary. And our whole goal is to make it seem fun, approachable, useful, and exciting. Every math class I've ever taught, my students said was like the most fun class of their day. And that's my goal. My goal is always to just find ways to make it change from scary to fun, approachable, useful, and exciting. Um, and I think the best way to do that is to go up in difficulty incrementally. Okay. So don't add too much too fast, add a little bit at a time. Okay. I think that's the best way to think about building examples and building these ideas. So that's going to bring us to our first one. So the first one we're going to do is linear equations. Notice that I'm starting with a PEMDAS example. So do now, please. So parentheses, exponents, uh, multiplication, division, addition, subtraction. So this is the lesson right before for solving linear equations. Notice that these skills that I'm having them use, the exponents, the division, all these pieces, is just to remind them about what they already know before they get into it. So this is a really good way of using a do now or an example to like try to remind them of what they should have already known to kind of build it. So this is about solving linear equations. I'd probably have other information here, but a linear equation is an equation where the highest power is 1. So we're not talking about x squared, we're not talking about quadratics, we're not talking about cubic functions, which is x cubed. But basically, this just means is that we have just like a regular x. Will they let me draw on this? All right, maybe I'll download it as a PDF so I can draw on it. I think that might be the best way to do this because I want to show you guys some stuff. Here we go. Now we have the power to draw. So basically, we're going to show our students that the first thing they have to do is multiply first. So this is going to be 8 minus 12. 8 take away 12. The negative's bigger, so I'm going to be left with a -4 here. Here's the next one. 2 times -4 is -8. You can distribute this if you want, or you can do the parentheses first. Because it's PEMDAS, I'm going to do the parentheses first. So it's 8 plus 4 times, and whenever there's not a piece here, we're going to just put a little dot here for multiplication. So -6 plus 4 is -4. So I have a -8 plus, oh, it's actually going to be minus because this is -16, which -8 minus 16 is -24. All right, here's the last one. There's an exponent inside this. This is a cubic, so it's a little cube. So this is 3 times 3 times 3, 3 cubed. So it's literally just going to be boxes of 9, right? And if we put them all together, length times width times height, we got 27 here. Now this you can think of as a big division symbol because fractions are the same thing as division. 48 divided by 8, we know is going to be a -6 plus 27, which is going to be a positive 21. So this do now really helps you go through it. We have definitions. So a linear equation is just something like 5x minus 10 equals 8. It's an equation because there's an equal sign. A lot of times we're going to see stuff called expressions, which don't have the equal sign. And whenever you have the equal sign, I always tell my students the opposite of PEMDAS is SADMAP, because usually we have to subtract first whenever we're solving. This is different from like a quadratic or a cubic, which would be like an x squared minus 4x equals 7. That's different because this is x to the first. That makes it linear. And inverses just mean the opposite. So multiplication goes to division, adding goes to subtraction, things like that. All right. So notice that the examples that I'm doing here start very simply. They were starting with just these pieces, and I'm just having them think about the inverse operation before they actually have to do the problem. So the examples in this lesson are really building. The first example they see is just in words, say what to do. So adding 4, the opposite is subtracting 4. Multiplying by -3 is dividing by -3. Subtracting by 7 is adding 7. And dividing by 8 is going to be multiplying by 8. So before they even try a problem, I'm just going to have them do this in words. Now, here's a little step for solving. So your whole goal is to isolate by doing the opposite of the variable. So I gave them a little goal first, and the solutions should always be just one x or one variable and the number. So I gave a little steps too before they get started. So they have to simplify each side, either distribute, combine like terms, isolate the variable by doing the opposite, and then we can check each answer by doing substitution. Now, I really like this lesson because every step the students have to write out. And I think that's really helpful because a lot of times when you do math, you're not actually understanding what you're doing. It's like you're not sure why you're doing what you're doing. But with these problems, I have justifications on the side, so I have to write it out. So the first step is always given. Then they have to isolate. So what is the opposite of multiplying by 3? Because there's a mini multiply here, they have to divide by 3. So they can write the property. This is actually called the inverse property of multiplication. But if you don't want them to write that, you can just say divide both sides by 3. And we're left with x is 5. And then, so you can just write QED, ed demonstratum, and that just means like as it's been demonstrated. And then we could do a little check. So we can substitute in for the check. So check by substitution. And this is really helpful because it gives them like the start of what they're working on. is 3 times 5 equal 15. You just substitute the 5 for the x. 15 equals 15, and we're good to go. All right. So the main thing I want you to notice as I go through these problems is that they're just getting a little bit harder. The first time is just 3x equals 15. The second problem is 2x minus 8 equals 10. So look, there's another number here. The next one, I have two x's on one side, a number on the other. The next one, the x's are on both sides. The next one has distribution in x's. And then there's a minus on the outside, and then there's a fraction. So every step, I'm just adding a little bit more to increase in difficulty so the students know what they're doing. So let me do a couple more of these for you. So the first step is always given. We're going to add 8 to both sides. You can write inverse property of addition, or you can say add 8 to both sides. But why do we add 8 to both sides? The inverse property of addition. So I have 2x equal to 18. We divide by 2 on both sides, which is the inverse property of multiplication. Divide by 2. And I'm left with x equals 9, which is our answer. So I can write QED, which means as it's been demonstrated, and that's Latin. They use it in a lot of big scary math groups. Then we check by substitution. Which is really just this 2. And I always put parentheses around it. That's where the 9 goes. Minus 8 equals 10. 18 minus 8 equals 10. And what are we left with? 10 equals 10. So it works out. And let's just try one more. So here, we have to put these two together. The first step is given, but then we're doing this. 11x minus 3x. So we are combining like terms. Or you can write 11x minus 3x, that's 8x. And then this is 12 minus 20. And then we have to combine like terms over here. So we're combining like terms again. We can combine them because these are x's and these are numbers. So that's 12 minus 20 is negative 8. We divide by 8 on both sides. And we're left with x equals negative 1, as it's been demonstrated. So how do we check this? Well, we write it in. 11, since I have two x's, I have to check by substituting. The reason why this is good for students to do is because nobody's just going to take their word for it. They just write x equals negative 1. You're like, how'd you get that? Did AI just tell you that? Like, how'd you really figure this out? So I really think the best thing to do is actually show them that. So it's 11 times negative 1 minus 3 times negative 1 equals 12 minus 20. 11 times negative 1 is negative 11. Negative 3 times negative 1 is that two negatives make a positive 3. And 12 minus 20 equals negative 8. Well, what's a negative 3 plus negative 11 plus 3? Negative 8 equals negative 8. And we have the right answer. Notice that this negative 1 had to be distributed to both sides. So for the rest of these examples, notice that here we have x's on both sides, so you'd have to move that x over. I'll just start this one. Notice that here we have to move the x over. So we have to subtract 3x to both sides. We always want the x's on the left. You always want the x's on the left. Why is that? Because when you start having inequalities, they're always going to point to where you want them to go. As long as you leave your x on the left, it's going to point exactly what you need on a number line or on a graph. So that's why it's so important to leave your x on the left-hand side. So I'm left with 2x plus 4 equals negative 12. Subtract 3x to both sides. Or you can say the inverse, it's really the inverse operation of addition, what we're doing. We're subtracting 4 on both sides. So I have 2x equals negative 16. So now we're dividing by 2. And we're divide by 2 on both sides. And I'm left with x equals -8 QED, and then you would check it. So the whole idea for this first one is just to show you that they're just getting incrementally a little bit harder as they go problem by problem. This one requires distribution first. You know, they all have little bits that just make them a little bit tougher. This one I have here because it's distribution with an X here, but students have to know that there's a -1. And this is like a common misconception. And we're going to spend a lot of time on that. There's going to be a whole video on just common mistakes. All right, so that's one way to show it. So let's look at another one. So here's another way to build difficulty in examples. So this is a conversion lesson. Basically, this lesson is really good because I have what research is using. It's showing students how to build a shared language. There's an interdisciplinary approach using cultural responsive teaching. There's kinesthetic, so they're going to be moving around a lot. And they're building class camaraderie between students. So I'm going to download this as well. Okay, just so I can write on it. It's going to take a minute because it's a big file. There's lots of pictures. And the reasons why students like this one is because I have GIFs. See, like there's movement, lots of fun for students. Students love, when I had a whole class where my students really love soccer or football. So that's why I made this lesson. And they seem to really enjoy it. I noticed that this one looks way more exciting than the last one. There's a lot of fun stuff. So let's start from the beginning of this lesson. All right, so it also has the assessment at the end. So the first thing, I was talking about examples and kind of like getting what they know, what they don't know. This is a great way to find misconceptions too. So the first thing I did in this lesson was to do what does not belong. And this means the students have to go to each corner of the room. If they go to each corner of the room, they could, and then they have, so they have to go to the corner of the room where they think the picture is different. Whatever one's different. They could say this one because it has a y-intercept that's positive, a y-intercept that's 0. They can say this one has a lower slope. They can say this one has the steepest slope. It's whatever the students want to have the reason that it's different. But you as the educator, you listen to what they're saying and you can kind of tell what they know, what they don't. So this is about conversions. So their job is to go to which one of these 4 boxes does not belong. Which one do they think is different? Do they know that this is division? Do they know that these are all types of decimals and percentages? Like where would they go? And whatever they said about this would give me a sense of how much they knew about the symbols and how much of the words. So this is a first example, unlike the previous one where it was like PEMDAS, where they go to the corner. And students like it because they, as a group, they must explain why they think it's different. And during the debate, let's say that you originally thought this one was different because it has 3 numbers next to each other, but they realized that this one has a decimal and a percentage. So they wanted to move to this one, they could. Okay, so this one I start with the objectives. I also have the Common Core Standard. You can see this is 6th grade. Everybody's in elementary school, so it's grades 1 through 6. So I thought this would be a good one to have all broken out for you. So the first examples that they have are just in words again. I'm really big on vocabulary. You'll see a lot in the lessons. It's tons of vocab. So they have to figure out what the word per means, miles per hour, points per game, words per minute. What does the word cent mean? Like how many years in a century, how many legs on a centipede, cents in a dollar. Just to get them to know that this means to divide by 100. And that gives them the symbol for percent or porcent. Then I give them history. Where does the percent actually come from? And this is really good for students to see, like, where does their information come from? Where is it actually shown? And then they do the same thing with fractions. Practice or broken. And they can see exactly when fractions were first used, when it was created in the Babylonians, Althusser, and Fibonacci used it. So the first to use the fraction bar was this guy when writing about inheritance of money being passed down. We've got pictures of them and just showing students we've got the numerator, denominator, and it actually shows them the symbol of the fraction bar. Okay. And then we have decimals or decimals. And we asked about if they use the base 10 system. Hopefully they can look at their hands and all the regions that use it. And this is decimal in the present. Um, so the way that these build, the way that these problems build is at first I just give them a simple percentage. Notice that they get more challenging. The first one's 7/100. You can't make it any smaller. So when you divide the 7 by 100, it actually becomes 0.07. That's all you can do. But the second one I give them, 20/100, they can go like this, 2/10, or 1/5. And then when they divide 1 into 5, they're going to get that 0.2 or 0.20. So this has another piece. Now this one, the 84/100, you can break down multiple times. So that's how it keeps getting more challenging as they go through it. And then the students really like it because they get to play a game. What is the game? It's a soccer game. They go in their group row, they push their desk together, but they did it too fast, or they didn't do it slow enough, whatever, or if they did it too loud. I would always make them, this is a way to teach protocols for students by getting into groups and you practice it. So I don't care how fast they did it, they have to come up with the group name and put their seats together. If it took too long, I would stop them, put the desk back, do it 3 or 4 times until they were able to do it. So seat penalty, calmly move your seat back, do it faster, safer, quieter, however you want. And how does the game work? They have to find the average, the decimal, fraction, and percent. Whoever has the highest average wins. And the way that this works is they have a missing soccer ball and they have to touch on the screen where they think the ball is. And the reason why I have them do this is because it helps them build communication with their other students. They're all just trying to help each other. One person when the team goes up, the other person says, oh, it's more to the left, it's more to the right. I can show you what one looks like just for the fun of it. So this is what it looks like. They get this and they have to see, and the other students are telling them left, right, up, down. So they learn communication, working together. That's a good guess. I was better than 70.22%. It's basically the game's being used as a number generator. And there's a million rounds in here that everybody can play. So, all right. Then on top of it, so after they've done this game, they have challenge stations. It just got harder. So now they have the numbers 0 through 9 on the board, and they have to use the digits 1 to 9 at most one time to make a true statement. So what divided by what is greater than these two numbers? Now we have to make 3 statements using just the numbers 0 through 9, and then there's two harder ones. Blank percent of this number equals this number. So I'm giving them these open-ended challenge problems that are also increasing in difficulty. Open-ended problems are the hardest for students because they don't actually have the numbers yet. Like, it's much easier to do a problem like convert 7%, but once they have to create it themselves using just a fixed amount of numbers, it's hard. And then we do a think, pair, share, which is always fun for students. What math symbols are there? They get to talk about it and their homework. So notice that I always give the students the answers to their homework as well as a video on how to do it. And for the homework, they have to write 3/4 as a decimal and a percentage, write 0.8 as a fraction and a percentage, right? 12%. The homework's getting more challenging as it goes along too. And they also have to create a visual image representation or a picture for each question. So they have to show me what they think 3/4 looks like. They have to show me what they think 0.8 looks like. They have to show me what 602% looks like. That really gives them a sense of it, right? About which, then after they have them all, they have to rank all the answers from least to greatest and then write a sentence about the values and why. Because Any student could type this into a calculator and get the answer. What makes it challenging is they have to draw the pictures like these. They have to rank them, and they have to say what they prefer. And this brings them to whatever we're doing the next, which is a pixelated picture, which is really cool for students. Students got to draw a picture, whatever they wanted, write the colors, the numbers, fraction, decimal, and percent. So that was a really good lesson for them to just kind of get the sense of what they are doing and the different pieces of it. So that's just another way to make it harder, how to show it goes increasing over time. I'll show you like two more of these. Another really good way is this is transformations, very common geometry topic that students are going to see. This one goes from very simple to very complex. I'm not going to go through all of it, but just so you can see how it happens. So transformations, transformers, they first have to start with the definition. The first math they do is just this smiley face, and they have to see which one is the exact same picture. How many of these are the same? Then the next thing they have to do is do that same process, but with a pre-image of a geometric shape. Then the students have to figure out which one is not an isometric transformation. We've got two circles, and then in their own words, they have to write the bond transformation. So again, vocabulary very big here. I gave them translation, which is a slide, and this is an actual translation with the proper notation. T stands for translation. This means we move 6 to the right, the Y stays the same. If it's positive, it's to the right. So here, I'll show you. So which ones are the same? This one, it's got to be exact same shape and size for it to be isometric transformation. So that's what it means. That's what isometry means. Same size and shape. Which ones look exactly the same? This one and this one, I think. Yeah, the rest are different. Which one is not? This one's stretched. Two circles are always isometric? No, because the size changes. So this is a no. And rotation is a spin. Reflection is a mirror or a flip. Dilation is a shrink or grow. That's a slide. I think this one you can think it's like a pull. So notice it's the same. This is your X and this is your Y. This means 6 to the right, no up or down, because it doesn't go up or down. This is a reflection. So little r, the y-axis just means we're reflecting over this y-axis line. All the match. There's the mirror. The rotation is a spin. So there's two parts of the rotation. This means the point of rotation. The first part is the 0 is the point of rotation, which means we're starting at 0. This means around the origin, because this could be, instead of a 0 here, it could be r -1, 2. So this could be around, we could be rotated around the point -1, 2 if we want, right? And this means we're going -90 degrees. So this is clockwise 90. So it's just how many degrees we're turning. So that's this origin of the spin. And this is how much it spins. And this is the same thing for dilation. So dilation is the grow or the shrink. So this is start of dilation. And this means the size. So this means we're going to double in size. If there's a fraction here, this would be 1/3 in size, 1/3 smaller. And if it's a -4, this is grow 4 times and flip over. They could have that too. And here's a stretch. I didn't go through the stretch because it's a little more complicated. So we just do the words first, but then this is the part where it gets more complicated. They just have to say the words isometry. Oh, wait, sorry. It's not the same size or shape. And this one's stretched. This one is the same size and shape, and it's rotated. So they just get to deal with these little alien monsters first, which I think students really like. That's what it starts. That's the last thing. It's just to get the words. So after they do it, isometry, translation, it slid, to get here. Then they do it with the shapes. So we go from monsters to the actual shapes. And then after the shapes, they actually have to do them. They have to draw the new shape and figure out exactly what happens. So I'll show you one of these. This one is isometric, and it's this one is isometric, and it's just a reflection. Okay, this one's not isometric, and it's a stretch. This is not isometric, and it's a dilation because it's the same shape. It just got a bigger size. Okay. All right, so I'll do one of these. There's a ton, and they get tougher. Oh, and then this is if you want it's a long lesson. I guess I went into dilations too because they were hard for students. But here, let's just do the first one. So these are the starting points: -1, 1, -4, 2, -1, and C is 6, -4. And we're going xy to x minus 5, y plus 3. So this is basically a translation of -5, comma 3. That's all we're doing. So it's yes, translation. 1 minus 5 is going to be what? -4. -4 plus 3 is going to be -1. 2 minus 5 is -3. -1 plus 3 is 2. 6 minus 5 is 1. -4 plus 3 is -1. So here it is. It's going to slide. Ready? Each point's going to go 1, 2, 3, 4, 5. 1, 2, 3. This is A prime, the first part. And you can see this is the point -1, 2, 3, 4, down 1. Now it's the point -1, 2, 3, up 2. Here's B prime. And C is going to be, ready? C prime is going to be 1, -1. Here's C prime. The triangle should look exactly the same, just slid over. And there it is. So there's the picture. Looks like the same size and shape. And that's how it works. So notice that this is just another way we can show more challenge, more difficulty as they get harder as we go through it. One more thing I wanted to show. I'll skip the proofs with Uno. I want to show I'll show this one, okay. So this is the probability grab bag, and I've got slides to it. If you really like this idea, you can. So this is what it looks like. The probability grab bag is basically, I use it for reviews all the time, and I have this one because probability, I put this one in here because probability is really hard, and it's one of the things that's going to be on your exam. So if you don't know what any of these questions are, you should totally try them. Notice it goes rookie, they're really easy. All-star, which is a little bit harder. Then I have MVP questions. Now, basically, what are the rules? So you cut up the problems, you put them in 3 bags: rookie, all-star, and MVP. Each student picks a card with a problem on it. The teacher has an answer sheet. I would always just do it right there. And you'll initial the piece of paper. In order to move from rookie to all-star, they complete 5. From all-star to MVP, they create 5. So rookie is 1 point, all-star is 2. I usually do 3 points for MVP because I make it like basketball, like a free throw, a 2-pointer, and a 3-pointer. And I usually have like basketball pictures when they try it. They just really like sports. Students really do well with sports. So, and students get this worksheet to go along with it. And they write all their work. 1 point, 2 point, 3 points, total points earned, and you have to get a minimum of 20. And students like it because there's competition and things like that. So here's all the things where they write it in. But notice that the questions themselves get harder. And every student can have a level. It's a really good way to differentiate for students because, like, even if everybody gets points, even if you're just doing rookie problems, you're still getting points. So I'll write some of these in. Where's the draw? Well, I'll just download it as a PDF. Okay, so when flipping a coin, what are all the possible outcomes? We got heads or tails. Ta-da. So easy. 1 point right away. But they don't know which one they're picking. They're picking out of a grab bag, and there's a bunch of these printed out in there. A coin is flipped. This is the probability of heads is 1/2, tails is 1/2. In a bag, there are 6 red, 2 yellow, and 5 blue. Find the probability of selecting a red. So it's what you want over the total. So red is 6. And the total is 6 plus 5 plus 2. Well, 6 plus 5 is 11, plus 2 is 13, 6 over 13. And now we want a yellow marble. So this is 2 out of 13. Now we want a blue marble. So that's 5 out of 13. This is a two-way frequency table. So if they want to know how many boys there are, you just look over here. 6 plus 10 is 16. How many girls is 12? How many people speak English only? So this whole thing is everybody who speaks English, but if we want English only, it's just this one, 35. And I don't know why I have a second one that's the same, but that's okay. Notice that I put the closest airport of the school that I did this in. But notice as soon as you go to All-Star, now what is the probability of landing 2 heads in a row? That's a heads and a head. So that's 1/2 times 1/2, which is 1/4. Now we're do ones replaced, right? So we do blue and then a yellow. So it's multiply. What is the probability of selecting someone who likes to swim? Okay, that one's not harder. And this one's how many people speak English. So that's this whole circle. So that's 35, 40, 65. So notice that they all get a little bit tougher, and then the all-stars are even more challenging of a problem. This is just a way to create more challenge as you go throughout it. Yeah, so obviously you can see these are tougher. And the last one I'll show you is this one, which has inverses. Notice that I'm using this way to double check. Here, I'm showing the steps. I've got all the steps here for students. A little bit harder of a problem, but the example problems start just by hand, then it goes to graphing. So I go by hand, then graphing, and then it's even more challenging because I give word problems. So that's another way you can increase difficulty. You can do by hand, just the problem, graphing, having to graph the problems, and then doing an application where you actually have to work out a word problem of them. And notice, just like all my work, we have the answer. So every problem that a student will have to do for me, whether it's the homework or whatever it is, they're always going to get the answers. And that's something you can do yourself. Same thing with the homework. I guess yeah, so this is the homework. So they have to do the steps and the graphing, but the only way that I'd accept it is the answers. And I have the answers here. So not only do they have the homework problems, but also the answers. I'm really big on giving the students the answers to the problem, and their job is to fill in all the steps in between. I don't want them to like not know if they got it right or wrong by the end. All right, so hopefully that was useful. This was the first one. This is curriculum sequencing examples. And then I'm going to do sequencing lessons after that. So I hope this was useful. Feel free to reach out if you've got questions about it, but I hope that was a useful first sort of lesson into trying to create a lesson. I try to give as many variations as I could, whether it was getting a little bit harder, where they're going example, graphing word problem, whether I was doing I don't even remember. There was a lot in there. So just feel free to try your best and good luck.